My name is Abdul Basit Hamud, and I'm here to present Hydrology project. So a hands-on hydrology project is officially underway to master the principles of water movement through direct field. The team is putting theory into practice. So the instruments and the math students are using student train gauge infiltration rate and measuring the real-time rainfall, soil and absorption. The data will be plugged into Harton's model, and the rational methods accurately calculate the rainfall runoff and also relationship. It is an intensive exercise in teamwork and technical reporting that turns raw numbers into precise environmental insights. Back to you.
Hello everyone, my name is Kumar Kumar. My meeting number is EF2501191. Today I am explaining about my hydrology project. Our project have three different types experiment. The first is rain cost data, and second one is infiltration, and third one is evaporation. Today I am explaining about rainfall data. First one, we do the model. The model from the rain cost data. First one is we take a plastic bottle, cut the top of the bottle, and the cut out of piece we put down and put the sellotape and put also the ruler with sellotape, because we find the value of the rain cost data. Then we put the water from zero value. On the zero value level, you put the water to zero value level. When put the place, the rainfall from the data, we got the rainfall in the bottle from the up to down. We got the rainfall data from here. When the rainfall the bottle, we got the actual rainfall data. After this, I put the video of how to do this experiment rainfall data. Later, my friend Halid continued the evaporation test.
Good day viewers, I am reporting live from Hydrology desk. Today we are diving deep into climate dynamics of Parit Raja, specifically focusing on our data collection at College Perwira UTHM. Our mission? To uncover how local weather elements directly drive the daily water evaporation rate over a consecutive of 14 days of observation window running from April 27 to May 10, 2026. Now you might wonder, how exactly did we determine how much water vanishes into thin air every day? We didn't just guess. We tracked four major atmospheric variables: air temperature, relative humidity, wind speed, and solar radiation. By compiling this daily field measurement into the Penman nomogram, we successfully calculated the precise open water evaporation rate, denoted as E naught. Now you might wonder, how exactly did we determine how much water vanishes into thin air every day? We didn't just guess. We tracked four major atmospheric variables: air temperature, relative humidity, wind speed, and solar radiation. By compiling this daily field measurement into the Penman nomogram, we successfully calculated the precise open water evaporation rate, denoted as E naught. Let's look at the head data. Over this 14-day period, College Perwira experienced cumulative evaporation loss of 54.55 mm, holding a stable daily average of 3.90 mm per day. But the real story lies in the daily volatility rather than a steady predictable line over graph show a highly dynamic tropical up and down cycle. Our highest evaporation peak hit on April 28, skyrocketing to 4.9 mm in a single day. On this day, conditions were optimal. A higher temperature of 27 degrees Celsius paired with a brisk wind speed of 1.8 meters per second. This moving air and intense sunshine rapidly transform surface water into vapor. Conversely, our lowest rate occurred on May 7, dragging the baseline down to just 2.98 mm per day. Why the sudden crash? Heavy cloud cover blocked vital solar radiation, while a saturated atmosphere left almost no room for water to evaporate. Wow, a fascinating look at our nature balanced water budget right here on campus. That concludes our deep dive into the evaporation dynamic at College Perwira. Now, back at studio.
Okay, let me continue for the infiltration data. My name is Tamimra Bakandra, CF 250170. Okay, for our experiment, I choose plastic bottle. I cut off the bottom and top part, so we have a flat surface here. Okay, and then I have marked around 2 centimeter from the bottom, so we can place it inside the soil, so it will become a zero level for the water inside lah. And then I have marked 5 centimeter and 10 centimeter for the water level. Okay, let's see how we're going to do the experiment. Okay, first place it to the ground until the level. So I put it here. Alright. Now we're going to fill in the water until 5 cm. Okay, while it's going down, we set the timer. So, when it reaches the ground level or the water fully go inside, we're going to fill it in again, and then we see how the water level, how many times it's going to be the constant level. So that's how we're going to find the infiltration capacity of the water. Alright, and then we just take note the data for the infiltration capacity, and then we can calculate the infiltration rate and all that. That's all.
Assalamualaikum and good evening everyone. My name is Nur Patricia Izzati binti Muazzidan, and today I will discuss and give conclusion about our project. So based on 40-day hydrology observation, we found out that rainfall, evaporation, infiltration and water storage vary at each study location. College Tun Fatimah record the highest rainfall data and Taman Pura Kencana record the lowest. The result also show the difference in evaporation rate due to the weather conditions such as temperature, humidity and wind. In addition, all study location and show good infiltration capacity, meaning the soil was able to absorb water effectively. Overall, the analysis showed that rainfall is main factor affecting hydrological process, while evaporation, infiltration and runoff influence how water move and is stored in the environment. In conclusion, this project helped us to understand the relationship between rainfall, evaporation, infiltration and runoff in tropical climate. Also, it help us to improve our practical, analytical and teamwork. That's all from me. Thank you.